Hi everyone, my name is Suwa Lee from the Stein Monogastric Nutrition Laboratory at the University of Illinois. I'll be discussing the effects of pelleting and reducing particle size of corn on net energy in diets fed to pigs that were group housed. This work was presented in 2023 ASAS Midwest meeting. Pelleting is a process of compacting and shaping feed ingredients into small pellets or granules. This thus helps in the ease of handling, transport, storage, and consumption of animals. Pelleting can potentially increase the digestibility of nutrients in pigs as well. The pelleting process involves heat and pressure, which can improve the digestibility of starch and amino acids in feed ingredients by breaking down protein structures, reducing anti-nutrition factors, and gelatinizing starch. Because pelleting also increases palatability of pigs and digestibility of nutrients, the growth performance of pigs is improved as well. However, because the process again involves heat and pressure, this may induce the heat damage of amino acids. Lastly, the diet costs more because this is an extra process. Reducing particle sizes of grains increases the surface area available for enzymatic activity and thus leads to increased digestibility of nutrients and also growth performance of pigs. However, because finely ground diets can generate dust and have negative impact on gut health, reducing particle size can cause health problems. Like pelleting, reducing particle size increases the overall cost of feed production because this requires additional grinding or processing steps. Energy is the most expensive component when formulating diets for pigs. Therefore, it is important to determine concentrations of energy in feed ingredients to reduce feed costs by maximize the growth performance of pigs. Equipment to determine net energy values of feed ingredients is available only at few universities in the world. But the University of Illinois recently constructed such a facility. This facility is installed with indirect calorimeter chambers that are airtight and have a capacity to hold the multiple number of pigs depending on size of pigs. It is possible that net energy in diets fed to group housed pigs is different from what has been determined in individually housed pigs. Therefore, this experiment was conducted to test the hypothesis that particle size reduction and pelleting separately or in combination increase nitrogen balance, apparent total tract digestibility, ATDD, of fiber and fat, and concentration of net energy in corn-soybean meal diets fed to group housed pigs. In this experiment, diets were arranged with 2x3 factorial and all diets contained corn and soybean meal. The first factor was the diet form, meal or pelleted, and then the second factor was particle size of corn. One batch of yellow dent corn was prepared and ground into 3 different particle sizes from 700, 500 to 300 microns. Pigs were fed ad libitum and had free access to water throughout the experiment. Because multiple number of pigs were housed in one chamber, pigs shared one feeder and water nipple. We utilized 24 pigs with an initial body weight of approximately 30 kg. There were 6 indirect calorimeter chambers and thus 4 pigs were housed in each chamber. The 6 chambers were allotted to a 6x6 Latin square design using 6 treatments and 6 periods to have a total of 6 replicates per diet. Feces and urine samples were collected for 6 days after 7 days of adaptation using the time-to-time procedure. Consumption of oxygen and productions of carbon dioxide and methane were also measured to determine the total heat production. Urine samples were collected during the fasting period and fasting heat production was also determined. Dried fecal samples were analyzed for dry matter gross energy, nitrogen, acid hydrolyzed ether extract, and total dietary fiber, and urine samples were analyzed for gross energy and nitrogen. The ATDD of nutrients and concentrations of digestible, metabolizable, and net energy were calculated, and retention of nitrogen was also calculated. Total heat production and fasting heat production were calculated using an equation suggested by Brouwer 1985, and we used analyzed gas data and nitrogen in urine for calculating them. Net energy was calculated by subtracting energy in feces and urine and total heat production, and then by adding the fasting heat production. The statistical model included diet as the fixed variable and period and chamber as random variables. Contrast coefficients were used to compare the two diet forms, linear effects of reducing particle size, and the interaction between diet form and particle size. Moving on to the results, let me set up the slide first. All data are presented per one pig by simply dividing data by the number of pigs in one chamber. The yellow represents diets in meal form, and orange represents diets in pelleted form. Within each diet form, there are 3 different particle sizes of corn that are 700 all the way down to 300 microns. The weight of oats from pigs fed meal diets was linearly increased by reducing particle sizes of corn, but this was not observed in pelleted diets. Regardless of particle size of corn, the weight of oats was greater in meal form than in pelleted form. In a couple of slides, we will look at nitrogen balance. The acidity of nitrogen was linearly increased by reducing particle size of corn in meal diets, but the effect was less in pelleted diets. The acidity of nitrogen was greater in pelleted diets compared with meal diets. There were no interactions between diet form and particle size of corn, and the effects of pelleting or reducing particle size were not observed for retention of nitrogen, that is, percent of intake. The average digestibility of total dietary fiber was about 63% in diet. Like the nitrogen retention, there were no interactions between diet form and particle size of corn, and no main effects were found. We are looking at the acidity of acid hydrolyzed ether extract in diets. The acidity of fat was linearly increased by reducing particle size of corn in meal diets, but the effect was less in pelleted diets. The acidity of fat was greater in pelleted diet compared with meal diet. For the acidity of energy, the acidity of energy was linearly increased by reducing particle size of corn in meal diets, but the effect was subtle in pelleted diets. The acidity of energy was greater in pelleted diets than in meal diets. Basically, the same thing was observed for digestible energy and metabolizable energy, that the particle size effects were greater in meal diets than in pelleted diets. Concentration of metabolizable energy was greater in pelleted diets than in meal diets. The increase in the acidity of energy and concentrations of energy by pelleting is explained by the fact that the heat generated during pelleting helps in gelatinizing starch, which is one of the energy sources in the feed ingredients, and thus making them more digestible for pigs. For net energy, there was a linear increase when particle size was reduced from 700 to 300 microns in both diet forms, but the effect was greater in meal form than in pelleted form. Regardless of particle size, pelleting increased the concentration of net energy in diets fed to group-housed pigs. Interactions were found in this experiment, indicating that the effects of reducing particle size were greater in meal diets than in pelleted diets. This is because pelleting also reduces particle size of grains, and thus the effects of reducing particle size in pelleted diets may not be as efficient as it was in meal diets. Regardless of particle size, pelleting increased nutrient digestibility and energy concentrations in diets fed to group-housed pigs. The similar was observed when the particle size of corn was reduced. I would like to acknowledge everyone from Dr. Stein's lab. If you want to learn more about the research we are conducting in the Stein Monogastric Nutrition Laboratory, please visit our website at nutrition.nsi.illinois.edu or search Stein and Pig on Google. Thank you for listening.